Welcome to the deep dive.
Yeah.
So if you've been watching the AI landscape, you know that LLMs have, well, they've moved way past just being fancy autocomplete engine.
Oh, way past. We're not talking about autonomous agents.
Right. AI systems that can handle these really complex multi-step tasks. Things like generating actual code or navigating websites.
We're even completing these elaborate virtual science experiments.
Yeah.
And that evolution to true autonomy is really the key.
An agent that can act, observe, and then react across multiple stages. That's incredibly powerful.
But as the tasks get harder, what researchers call long horizon tasks, the real challenge becomes, how do you teach the agent to learn when it messes up?
How does it actually get better from its mistakes?
Exactly. How does it effectively acquire, store, and then use that new information?
Okay, so let's unpack this. We've been diving into a new framework called Critique-Guided Improvement, or CGI.
Mm-hmm.
And its core mission is, well, it's pretty radical. It's shifting feedback away from simple numbers, the current standard to detailed natural language instructions.
You're not just giving it a grade.
No, it's like giving the AI a personalized mentor instead of just a report card.
And that's where the deep insight is. You're moving from these, low information numerical signals to high quality guidance. And it's delivered in the language the models understand best. It just fundamentally changes the learning loop.
So for this dive, we're basing our discussion on the research detailing this CGI framework and its experiments across a few of those complex environments you mentioned.
Right. Webshop, Science World, and TextCraft.
But before we jump to the solution, I think we really have to appreciate how big the problem is. What is the status quo and why does it break down?
Okay, so the standard way agents learn relies on something called scalar feedback.
Scalar, so
Yeah.
a single number.
A single number, exactly. You train these external verifiers or reward models, and all they do is produce a score. Think of a method like best of n.
Right, Bon. The agent comes up with 5 ideas, and the system picks the one with the highest score.
Yep. And that numerical feedback is just so limited, right?
It's barely any information to learn from.
It's critically low in what they call informativeness. The score tells the agent which action was best out of the 5 it just generated, but it says nothing about why the others failed.
Or how to fix the thinking that led to them.
Precisely. You're reducing all this complex strategic guidance down to one blunt number. It's a filter, not a teacher.
So if numbers don't work, the logical next step is language. Why can't a huge LLM just critique itself? Shouldn't that work?
You'd think so, but in practice, that approach tends to fall flat. There are really 2 big failure modes here.
Okay.
The first one is what the paper calls weak feedback. The self-critique just depends on the LLM's own general abilities, and when the task gets really complex, the model just starts to hallucinate.
It makes things up.
It makes things up, or it generates this really low-quality, unstructured feedback that's actually worse than useless sometimes.
So it's trying to give itself advice, but the advice is just not actionable.
Exactly. And that leads right into the second problem. Poor utilization.
Poor utilization.
Yeah, even if you get a rare, decent self-critique, the agent still struggles to, accurately interpret and integrate it. Its original flawed plan is kind of baked in from earlier training, and it resists major changes.
It's just not flexible enough to pivot based on that advice.
Right. So this sets the stage perfectly. Agents are failing because scores don't teach them, and they're failing because they can't trust or use their own advice.
Which brings us to critique-guided improvement, this 2-player framework.
It's a really elegant decoupling of roles. First, you have the actor model.
The doer.
The doer, yeah. It interacts with the world, it explores, it generates the candidate actions. And then you have the specialized critic model. Its only job is to provide that supervisory, detailed, natural language feedback.
And the loop is simple. The actor suggests things, the critic assesses them and suggests revisions, and then the actor refines its action and does it.
And this is where the story gets really compelling.
This is the part that I think really challenges the industry's obsession with just scale.
It really does. So the researchers tested this by taking a relatively small model, Llama 3.8b, and they specialized it to be the dedicated critic.
And what happened? I mean, you'd expect a small model to just get crushed by the giants, right?
You would, but it was the complete opposite. That specialized Llama 3.8b critic significantly outperformed the state-of-the-art GPT-4o model.
Wait, significantly?
And I mean significantly. The critiques it generated led to much higher performance for the actor. We're talking an improvement gap of over 29%.
Wow. That is a massive finding. It just flips the script on the idea that you need a huge general-purpose model to be the best evaluator.
It totally does. It shows that for mentorship, for focus guidance, specialized training trumps sheer size.
So intelligence here isn't just about raw knowledge. It's about the ability to give good, actionable instructions.
Absolutely. So the obvious next question is, what makes the Llama 3 critics' feedback so much more effective? We should probably dive into the structure of that critique.
Right. It's not just a random paragraph of thoughts. It's really organized. It has two core parts: discrimination and revision.
Exactly. And the discrimination part is where the critic really acts like an analyst. It grades the action against three very specific, predefined dimensions. It's like moving from a check mark to a full grading rubric,
Okay, so the first dimension is contribution.
which is all about strategic value. You know, how well does this action actually help solve the overall task? Is it a step forward or a detour?
Makes sense. Second is feasibility.
This is the basic validity check. Is the action even possible? Is it formatted right? Is the thing you're trying to use even there?
And the third one, which feels maybe the most strategic, is efficiency.
It's crucial for optimization, yeah. It asks if the action is the most direct path. It helps the agent avoid doing unnecessary redundant steps.
So after it analyzes those three things, the critic gives an overall grade: excellent, good, poor, etc. And then, most importantly, it generates a suggested revision.
This is the teaching moment. In the science world environment, for example, the goal might be to check the water temperature. An actor might just propose, go to bathroom.
Right.
And the critic steps in and says, whoa, wait, you skipped picking up the thermometer. The revision isn't just no, it's a specific instruction. The agent should pick up thermometer before attempting to go to bathroom.
That's the crucial difference. A number just says which action is best. This tells the agent why the others failed and exactly how to fix its reasoning.
It's like getting notes from an editor instead of just a rejection slip.
But as we said, giving the perfect critique is only half the battle. You still have that poor utilization problem.
You have to solve that.
So now we have to focus on the second part: teaching the actor to actually use that perfect critique. Because even with great advice, if the actor is too rigid from its initial training, it might just ignore it.
And that's the policy misalignment problem. The agent's policy is resistant to change. They saw this in the science world tests. A fine-tuned Llama 3.8b just kept trying to go to bathroom, even when the critic was telling it to look around first.
It was stuck. It created a deadlock.
Total deadlock. So the solution was all about the training data. They didn't just retrain the actor on good outcomes. They trained it specifically on how to take advice.
Through iterative SFT, right? Supervised fine-tuning.
Exactly. In each round of training, they collect two critical data sets. The first, which they call decorrect, is just successful trajectories. That's learning from success.
And the second data set, derefine. This is where the magic happens, isn't it?
It is. Derefine is the data set of critique action pairs. So if decorrect is like reading the textbook, derefine is like going over your mentor's corrections on your essay.
It shows you exactly how to turn bad reasoning into a good action.
Precisely. It trains the actor to map a negative critique to a positive revised action.
And the ablation study they ran, I mean, that confirmed just how important this was.
It was an absolutely critical finding. They tested what would happen if they removed each data set, and when they removed derefine, that collection of critique action pairs performance just cratered.
How much?
It dropped from a nearly 69% success rate all the way down to 50%.
Wow. So that proves it. Enhancing the actor's ability to actually use the critique is the single most critical factor for improvement.
It's not enough to be told what to do. You have to be trained how to listen.
Which brings us to the payoff. For you, the learner who wants to see results, CGI really delivers for the agent.
The performance numbers are impressive. That Llama 3.8b actor with its specialized Llama 3 critic got an average performance score of 61%.
And compare that to the baseline.
The baseline with no critique was stuck down at 12%, and using the best numerical discriminator only got it to 23%.
So CGI isn't just a little better. It's a monumental leap.
It's sustained improvement, all by focusing on quality guidance.
And it also made the agents more efficient, which is a huge real-world win. The qualitative analysis showed that the most significant guidance happened right at the beginning.
Yes, in the early stage decision-making, that's key.
Why is that so important?
Because by correcting the agent's flawed reasoning right out of the gate, it conducts more effective exploration faster. It wastes less time on dead-end paths and gets to a high score in fewer steps.
And this framework really shines where other methods fail, on complexity.
Correct. CGI showed the greatest improvement on those long horizon or hard tasks. Those are the ones where an agent needs sustained guidance to avoid getting stuck, which happens all the time with self-reinforcement methods.
So what does this all mean for the future of agents? It feels like the framework proves that intelligence isn't just about raw power or picking the best option from a list.
I think that's exactly right. It's about structured, articulate mentorship. It's the quality and the applicability of the feedback delivered in the language the model understands best.
We have clear evidence that two smaller, specialized models, an actor for doing and a critic for evaluating, can beat much larger general models.
The power is in that purposeful conversation.
So if this is the key to unlocking sustained improvement in AI agents, this explicit, structured, verbal guidance, this two-player model, it raises an important question, doesn't it?
It really does. What can this framework teach us about the optimal way humans learn and internalize complex knowledge ourselves?
Yeah.
You have this model of one specializing in exploration and the other in strategic evaluation. What does that teach us about our own learning process? Do we just need better critics, or do we need better training on how to actually use their feedback?